Hey everyone, thanks for joining. I'm just getting started. If you came and found this from the Real Scientists page, welcome. It's been awesome hanging out with you guys this week. If you weren't aware, it's Twitter at Real Scientists. I'm hosting it this week to talk about World Space Week and about all my weird careers in science. So I've also had a few subscribers since the last time I was here. We have Lauren Malin and Super DTG all subscribed, so thanks guys. And then as well, if any of you guys are interested, you can subscribe. I think it's still September, so it's half off. Or you can just donate, and there's a bottom. There's a button on my page. So welcome. We're here to talk about Star Trek Discovery. If you weren't here for my talk last time, we went into the science of episodes 1 and 2, of which there was a lot. This episode, there's not as much science, but what was there gave us things to talk about. My friends and I were in a texting storm during that. So feel free to use the chat window. If you've got questions, we'll try to come to them later. And then at the end, we'll probably do some geeking out just about the episode in general, because friends. All right, so thanks again for joining. Hit me up if anything's not working. I'm still figuring some of this out. But let's get going. So let me see. Yes, first scene when they are hanging out in the shuttle on their way to Discovery. Initially, when I saw this, I thought it's warp drive. Like they're in warp, right? They're obviously in warp. And then weird things were happening that made me think that maybe they weren't in warp very much. There was a few things. The first one, my notes, by the way, are hilarious. There's lots of questions and shouting at this. But basically, when you see this, I thought it was at warp. And then remember, they jiggle a little bit, and the pilot goes outside to do an EVA, an extravehicular activity, which means they go outside to figure out what's wrong and repair things. And I went, EVAs during warp, probably not ideal. But then it kind of, as like these little weird creatures showed up, I started to realize maybe they aren't at warp. Maybe they're just in a nebula, which we've seen in some other Star Trek, and we've seen like in Doctor Who and that sort of thing. So yeah, let me see. These little weird spores start crawling down the window, and they talk about this being something that like feeds on electrical energy, and if they stayed out there, then they would drain all of their power, which I think was in a Doctor Who episode as well, but I can't remember if it was a Star Trek or a Doctor Who episode. If any of you remember, please tell me, because I didn't have time to go back and look all of these up to figure out what episode it was that was dealing with a creature in a nebula that was sucking energy from the power, feeding off of the power. So sorry. Let me see. So we have these weird spores that are feeding off of the energy that are on the outside of the ship. We still don't know a ton about them, but they're kind of creepy and kind of cool. So, fun to look at. And let me see. Then we're gonna get well into this. And then the shuttle arrives at Discovery, right? And not super huge fan of this, mostly because I'm trying to figure out how they do it. So and we've seen this in other sci-fi and in Star Trek, but they have like a shielding wall, and then the shield opens up a little bit and they fly through. And on the angle, I couldn't quite get the picture of this because I can't freeze frame and take the picture. I have to do it during the action. But you can see there's like stuff in this shuttle bay that's not moving, so it's not being depressurized. So when that hole opens, that means that it's not being exposed to the vacuum of space, because if it were, all of this stuff would fly out. You'd see like all this air effects from the air rushing into the vacuum of space, trying to leave the ship. And we don't see that. So what that tells us is either it's all tied down brilliantly, would be cool, or it is somehow protected. So there's like a instantaneous two-stage shuttle entry for these ships in order to not have a massive decompression. And there was an episode of Next Gen where, remember, the storage bay was going to decompress when all the things are going bad on the ship. But I'm not sure how this would work. Again, if any of you can recall this from previous Star Trek, where they may have addressed this idea of the shuttle bay entry not decompressing when they open it. But yeah, it's weird. And so kind of works, but it made me pause for a second. So then we get into the episode, and I have Cylon, ! Saru, ! And then Jason covered in little hearts. Won't get into that. We're here to talk about the science. So cool thing is when Michael goes and meets the captain for the first time, I just really like this, that you can see in the background the map of what is clearly like the Federation Starfleet and the Klingons and their border. And I wish I could get a better picture of this, because super cool, right? And just neat to think about. And it comes up later where they are in the quadrant, which again, I'm a little bit confused by, because there's some references to distances later. So this is why I wish I could get a good view of this map. If anyone's able to get it, please send it to me, because I'm really curious where they are. Obviously, we've played with different quadrants in the edge of Federation space and Klingon space, but this is the first time we're really getting into the Klingon War. So without going too much into like the canon books, we don't really have a good idea of where in the quadrant this is happening, other than we kind of assume it's the Alpha Quadrant, which again, we'll get to. We're going to get to this. So there's a lot of discussion about quantum physics and physics in biology is this whole episode. And if any of you have seen me talk at DragonCon with my biology counterparts, Mohammed Noor or Eric Spana, it was a little hilarious how this was physics and biology meet, because that's what we do. So it's like that they wrote our talks for the next Comic-Con season for us. So thanks, guys. But yeah, so there's the map of the Klingon boundary. Then black alert happens, and weird things start happening. So you can kind of see this picture here. These little water, like threaded sort of water droplets show up that are going throughout the room and throughout the ship. And Michael doesn't know what's going on, so Tilly won't talk to her because she hasn't been briefed. And so we're trying to understand what's actually happening. And that's kind of the theme through the whole episode, is this weird mystery of these like pseudo-biology physics intersection that we don't quite know about until the end of the episode. But basically they go into black alert. She sees, let me see, yes, I got the picture of that. So she sees these like droplets of water that are somehow appear out of nowhere and then aren't affected by gravity. They're just kind of floating around like water does in a zero-G environment, but it doesn't seem like she's experiencing a zero-G environment. So it's a little bit weird there. But, you know, all right, we're still trying to figure out what's going on. I have lots of exclamation points and question marks during this bit because I don't know what's happening. And so we see these water droplets. They appear. There's this black alert. We don't really know what's going on. Let me see. And we go on. We meet the engineer, Stamets, Lieutenant Stamets, who was kind of cool, kind of grew on me throughout the episode. But I spent longer than I should have trying to figure out what this code is doing, and it's basically opening and parsing a file is all it's doing. It's not terribly interesting. I was really hoping for some little nugget in there. If someone found a like an Easter egg, then tell me, please, because I tried to see what we could learn from the code. There wasn't that much, unfortunately, but we try. So there's a lot of interesting discussion with the engineer about quantum astrophysics and biochemistry. And Michael's like, well, I thought it was quantum astrophysics, but now I think it's biochemistry. And I'm not quite sure what's going on. Thanks for following. And they start talking about like gene expression and all sorts of weird things are happening. So then this happened. I'm sorry, I'm not a biologist. I'm an astrophysicist. So a little bit in Michael's position here, trying to figure out what's going on. Breath entry to doors, to locked doors. Is this a new Star Trek technology, or is this because they have secure facilities? They always had this technology, but remember, they don't have secure, like, having weird closed off classified regions is bizarre for Starfleet. So, yeah, the breath technology. Not sure about that. I think where they're coming from is the idea that you can get your DNA from saliva. And when you breathe, obviously there's some water vapor that is your saliva. When you breathe out, that's like it's humid, it's warm air, which means that there must be some water droplet type signature in your breath that could contain your DNA, and then it would be immediately analyzed. Not quite sure how this works. And then they take it even a step further when Michael uses Tilly's saliva and uses the aerosol to spurts it at the breath sensor. And yeah. So again, letting credence to this idea that it is just vaporized saliva that's going into this breath signature. But then you have to think, all right, what part of the DNA sequence are they trying to read? Are they sequencing the whole thing as an individual fingerprint, or are there just portions of the DNA that they need to analyze? I am definitely going to be pulling my biologist friends in to do like a proper VOD video episode. So if you guys are watching, sorry, that's happening now. But yeah, there's like this, so DNA print off of the saliva, not quite sure. Thanks for following. And then they start talking about the chief engineer's buddy and on the Glenn, the USS Glenn that was lost. So they are talking about black alert maneuvers and all sorts of weird things like that we don't totally understand. Then when they come in to make this announcement, they say, well, we can't transport the remains because they're shielded. And I've talked about transporter technology a little bit in the past, but I'm going to talk about it now because Star Trek, and we can, before I get into angry biology physics stuff. But we don't, the tricky thing is with transporter technology and Star Trek is they are not super consistent with how transporter technology works. So there are kind of two fields of thought. One is that you're broken down into your quantum particles, and then those particles are actually moved at the speed of light to another location, to another transporter pad, and then you're reassembled. That idea kind of comes a little bit from things like where they're held in the transporter patterns. I remember in Voyager when they're trying to hide the empaths, I think, and they hide their transporter signature they suspend their transporter signature. So that kind of makes you think that they're breaking down into particles and then being suspended / transported. And fun fact, I tried to figure out if how long it would take, like if they're going at the speed of light. And so I tried to see how long it would take for particles to go at the speed of light as the crow flies from San Francisco to New Orleans. Thanks, Cisco. And it's like 0.1 of a second, I think. Or 0.1 of a second. Yeah, was about right. So 10 milliseconds. And 0.01. Math. But yeah, as the crow flies. So that's one possible way of doing it. The other way is that they actually kill you. Yeah, so like they're cloned via transporting. And this is the problem. Thanks, Swizzlemania. Absolutely. So the theory is that they were cloned via transporting. And that was the episode with Riker. And there's a few other episodes where they kind of make you think that they're killed and then reassembled at the transporter pad. Whatever their signature is then reassembled. So the different, and I'm not going into every example for each theory, but this is a constant question of mine of which one is kind of favored. And probably when I take a staycation or something, I'll go through and try to figure out which one is favored more than the other. But yeah, there's the cloning episode with Riker that kind of makes you think that they're being rebuilt at their location. So anyway, but they mention more transporter technology here because they say, well, we can't transport the remains of the USS Glenn because it's being shielded. It's shielded. So that, again, doesn't answer our question because it could either be that you need to break down the component particles and then move them, or you need to just map whatever it is and then break it down, kill it, and then rebuild it. And I think Enterprise goes into this a little bit too because, like, I forget the character's name, but she's really afraid of being of using the transporter because of this, because she's afraid of like being killed and rebuilt, but then conflicting canon. So good times. But they say that they're shielded, so they can't transport the remains of the Glenn out. And then let me see. Then they go to the Glenn and they try to figure out what happened, try to investigate it. And one interesting thing here, so they're at warp and they drop out of warp. And then they have comms back to the ship that's giving them instructions. They say, all right, approach the ship, whatever. Which means those are FTL communications. And we've talked a little bit about this before, too. This idea that Star Trek pretty much uses quantum entanglement as a concept for communications, which is possible if you're coming from the same ship or the same origin, that you are able to sustain these entangled particles in order to use them for communication, for voice communication. And the voice bit is the tricky bit, and that's the one that kind of made me sit up. Because, again, we see FTL communication all the time in lots of sci-fi, but in Star Trek especially. And pretty much the way that it works is that you have to have quantum entanglement in order to do that. So that was interesting. And then they're trying to figure out what happens, and now it begins. So lots of discussion of biology is physics. Physics is biology. There is no difference at the quantum level. Spores are the building blocks of physics as biology. And there's a lot of discussion about the superstructure of our universe. And what he's alluding to there is this. And I suspect the writers were going off of this as well. I usually don't watch like After Trek or the discussions with the writers because I like to try to piece together the science myself, just using my own experience, my own background to see what they were inspired by, but to possibly piece together on my own. Because sometimes I found like they've accidentally done the science really well. But this one, someone told me that they watched there was like a TED video that they were kind of inspired by, and I watched some of it, and it's pretty much using this idea that this image that you see, thanks for following, this image that we see here is our superstructure of the universe. So this is a simulation that we've pieced together, that all of those threads and all of those kind of big clusters are galaxies. So we call it the superstructure of our universe, and it's pretty cool. You can actually see it. So I, back in the day when I was an undergrad, I did some radio astronomy, and one of the cool things that you could see is as we're stepping through distance and time, you could actually see threads. Try to get the... So you can see like galaxies as you're going away all in one line. And that's this structure. That's like that superstructure of the universe. And lots of studies trying to figure out why it looks like this. Basically, there was the Millennium simulation that happened. You can watch a YouTube video of it. And it was a while back. It was like 15 years ago or something. Where they basically took a bunch of matter, just uniform distribution of matter, and let it run. And just let gravity take over and start to see how it clumps out. And this is the sort of structure that you get from it. But then it really inspires a lot of like sci-fi imagery, right? Because we have like that kind of looks like neurons or fungus. Lots of other things that we see in our universe have a similar structure. So it's inspiring from a storytelling standpoint. From a use of science standpoint. Ooh, baby. So a lot of this is just the idea that maybe if you think our universe looks like this, maybe it is populated with fungus. We'll get to that. Before we get there, when they arrive on the ship, activating shuttle bay containment field override. Again, I was trying to piece together this shuttle bay containment field. Thanks. So I was trying to piece together how these would work, and all they alluded to was a shuttle bay containment field, which, again, we've heard that kind of before. But there was stuff in this shuttle bay. So, again, they must have like a 2-stage decompression chamber so that doesn't all fly around when they enter. I'd like to see more of that. Then they arrive, they talk about the power of redundancies, and the relays are all shot, so they're in the dark, and my knees are up at my chest, and I'm screaming at the television and frightening my neighbors, because it's creepy. I basically wrote Reavers all in exclamation points, because we've seen this before. And it was creepy, but fun, but creepy. And then there was a lot of me shouting at the television. Not much science, other than the fact that Klingons are gross and squishy. And I'm not even putting, like, humans are gross and squishy, Klingons are gross and squishy. I'm not even putting the pictures on there because obviously Klingons are very squishy and also bodies warped around. So I study space. All right. Yeah, it was horrifying. Then this was pretty cool too. So trying to get through the doors, blast doors, using oh my gosh, using a blaster, right? Using a phaser. Sent phasers to stun. We're not in Star Wars. We're in Star Trek. Phasers. Looks like using plasma from the phasers to try to de-weld the door, basically. Again, Liam Neeson did this with a lightsaber in The Phantom Menace. Similar idea, though. So, I've talked about this before on the last episode that I did, but plasma is a superheated gas. So we talk about the different types of matter. You have solid, liquids, gas, and then you heat gas up even faster, and it starts to ionize, and then you get plasma. And really high temperature, you can do things like that. So she's using plasma from a phaser, I think, or a blaster. They have weapons and like tactical vests, and I'm really confused is what it comes down to. But yeah, I mean, in theory, you're melting something the same way you would weld something. You're melting this metal, you're melting the lock using plasma. It works. Science works. Jeffrey's tubes. I was so happy to see Jeffrey's tubes. Creepy monster coming after her, but mostly just excited about Jeffrey's tubes. And Tribbles. We have Tribbles. Star Trek. Tribbles show up. Will they appear again? Are they breeding in the bowels of these Jeffrey's tubes that we know these ships have? We don't know. We're still trying to figure out. All right. And all of that's fun. Star Trek rules. Okay. So, again, if some of you are new because you found me from Real Scientists and not from my time spent in conventions, I talk a lot about faster than light travel. My PhD was in gravitational waves, general relativity, Nobel Prize winners. So I talk a lot about how faster than light travel would work. And I spend far too much of my free time trying to piece together how faster than light travels works in different science fiction. A lot of it is doable. I'm a theoretical astrophysicist. Engineers can build it. I can do the math. I can show that space-time will allow you to go faster than light by warping space-time. And I have a few videos I've posted about how FTL works, and I'll go more into like other fandoms, things like that. But, this. Yeah, this was, thanks guys. Yeah, FTL is awesome, and I joke around with it all the time. Hey, Cypher, thanks for joining. So yeah, it's, this FTL discussion. Oh my gosh. I don't even know. Okay, we gotta begin somewhere. So we're gonna go with how they explain it in this. So in the episode, we've got, spores that are showing up around the ship. There's this weird, black alert where stuff gets funky, like anti-gravity water shows up, and we don't know where that's coming from, but we see these spores on the outside of a ship that I assumed was in a nebula at the beginning of the episode, that feed off of power. And then there was a lot of discussion about the superstructure of the universe and how biology and physics are all one and the same thing. And I cry because I didn't like biology and I loved physics. And if I have to now learn a bunch of biology, I'm not happy about this. So all of these spores show up, and he tries to explain to her this technology that they're going for. And like me, and I think as the story intended, we think that they are building a weapon because Starfleet is apparently more militaristic now, and that's confusing and hard for a lot of us Star Trek fans. Yeah, I promise you I'm getting through this. So they're not building a biological weapon based on spores. What they're doing, as he unveils to her here, is that they're building a travel network using fungus in the universe. I committed. We're doing this. All right, we're in. So the theory is that our universe is filled with these spores. If galaxies look like weird neurons and fungus in their big supercluster formation, they look like a fungus, so there must be a fungus out there that permeates our universe that possibly is in another dimension. I will admit, we don't know everything about our universe. There are still things that we can learn. We don't know what dark matter is. We don't know what dark energy is. We try to figure them out. Maybe, please don't quote me on this. Please don't hold me to this. Maybe dark matter is a bunch of spores and a big intertwining fungal network throughout our galaxy. So I'm going to go back to math because that's my happy place. He mentions that they're using this fungal network as a way to travel through space. Instantaneous FTL. So I'm getting really worked up. What I like to phrase this as, most science fiction deals with three types of faster than light flavors, really. Three different flavors of faster than light travel. We have warp drive, which is where you build the bubble around the ship and you use space-time to propel you through space-time because you're able to... so you can't travel on the surface faster than the speed of light, but if you can bend space-time, then you're able to... there's nothing that says space-time itself can't travel faster than the speed of light. So House 414, thanks for... I saw a video where it's kind of like magnetic drive that draws in space and expels. Yes. So in that example, the ship was stationary and space was moving. Yeah. So that's how warp drive works. It can be a combination of those. So again, if you build a warp bubble out of space-time, basically what happens is you can bend space around you and then it moves. Try to show you. So it's moving as it's moving around you. You are still existing in a happy, flat space-time where physics isn't breaking. But you are bending space-time around you and kind of riding this bubble through faster than light, which is physically possible. It works. The other flavors of faster than light travel that science fiction uses are jump gates and jump drives. So jump gates are like wormholes. Wormholes are a similar way. Wormholes are typically naturally occurring, and jump gates are usually artificial. Think Stargate. And the way that it works is space-time is all sort of weirdly bent, and basically you punch a hole through. Now, either that hole already existed and you're able to access it, wormhole in Deep Space Nine, or you are able to utilize these point-to-point jump gates that were made. So you can't alter where they're going. They go from one point in space, and then they shortcut you to another point in space, where it's basically folded over and it's just a quick shortcut. Think Mass Effect, think Stargate. That's how that works. And then the last way is a jump drive. Now, Battlestar Galactica and Dark Matter are probably the best examples I can use for that. So, Battlestar Galactica especially, because they actually spend a long time kind of explaining some of the technology with it, but they spool up their jump drive, their FTL drive, which takes time. And what they're doing is they have space-time, and they're bending it to them. They say, I'm here, I want to go here, so I'm going to bend space to me, and then we're going to unbend it, and I'm going to end up over here. It's tricky to do. These are all tricky to do because if you're going to bend space-time and you don't have the mass to do it, you have to use an equivalent amount of energy. And if you're going to be bending space-time all the way to your ship, not just locally around your ship, but from where you want to go, it's going to require a huge amount of energy and time. So House has another question. What about the timey-wimey TARDIS? What would that be? So the TARDIS is also like warp drive. So it basically propels itself through because it is kind of choosing where it's going, and it travels through time as opposed to space. I've got a few videos I have planned for this. The TARDIS doesn't go a ton into technology, so you can maybe sort of explain it as a jump drive, but then, yeah, for another time. We could get into that a lot. So, okay, getting back to Star Trek, though, because that's what we're here to talk about. If we're starting with these three flavors of faster than light travel, this isn't any of them, which makes me not happy. I mean, I love it. Star Trek, but all right. How do we make this work? One way that we could make it work is this idea that we have fungus that's permeating our whole universe. Let's imagine, for example, it's dark matter. Hard to do, but we're going to say that it's dark matter. This fungus just exists. Now, the first question to ask is, can fungus exist in the vacuum of space? And no would be the immediate answer to that, based on biology on Earth. But we are still learning things, and there's a lot to learn about space. And one of the cool things that we've discovered recently is there is bacteria that has survived longer than it should have on the outside of the International Space Station. They didn't expect it to survive, and it did. Being studied more, not totally definitive, but there might be weird things with bacteria and the vacuum of space that we don't totally understand yet. Yeah, thanks, Neostar. We're getting into that. Again, I'm not a biologist. I'm an astrophysicist, which is why I kind of connect with most of Michael's face through the entire episode. What is happening? So, okay, we need fungus to exist in the vacuum of space if this is going to work. The other thing that we need to make work for this is that it all has to be the same fungus. Now, Star Trek takes place within our own galaxy. And sorry, House, if I'm spoiling this for you, but it's fun. Because it is a kind of a cool reveal, but still. Whew. So Star Trek takes place in the Milky Way galaxy. And I've got a VOD on my Twitch channel and my YouTube channel, same name, that explains the cosmological address for those of you who might not be familiar. And I blame most of science fiction for this, with love, but blame, because they intersperse the terms star system, galaxy, universe as all sort of interchangeable, which confuses people, understandably. Things like Firefly, Battlestar Galactica, those take place in star systems, where you have a sun or maybe a few stars, a few suns, and their respective planets, and they're all kind of in some gravitational happy place together. So you have star systems, and then you zoom out from that and you have galaxies. And galaxies are made up of star systems. So think about it as cities within a state. And then galaxies contain all these stars, 100 billion stars. And then galaxies make up our universe. Again, we've talked about the weird structure of galaxies, this hyperfine structure. And there are concentrated pockets of galaxies. We call those galaxy clusters. But on the whole, that's a basic way of doing it. So you have star systems, galaxies, and then the universe. Now, they are, in this, kind of conflating the two as well. Because they talk about the superfine structure of the universe, sometimes it's hyperfine, superstructure of the universe, which is the thing that looks like biology, looks like neurons, looks like fungus. But Star Trek takes place in one galaxy. It takes place in the Milky Way galaxy. So this concept of using fungus, all I'm trying to get to is it would have to be everywhere. Because throughout the universe, not just our own galaxy. And the reason I say that is just because, thanks, Cypher, I appreciate it. The reason I say that is just simply because our galaxy is a certain age. The universe is a certain age. It started out, Big Bang happened, lots of gas. The gas started to clump into stars, which clumped into galaxies, which merged and made bigger galaxies. And there's a galaxy and star evolution over time. If you're going to have a fungus, we're just saying fungus, short term for whatever this is. They say spores, fungus, whatever. If you're going to have a fungus be permeating our entire galaxy, then it would have to permeate the entire universe. Now, going on from here, though, they kind of try to explain it. I'm going to eat every mushroom I can find when I go on walks in the hope I teleport to the Kepler system. Good plan. You may teleport to the Kepler system without actually moving anywhere. Not condoning that. But you're welcome to try. So, again, these spores would have to go throughout the entire universe. They do talk about the issue of distances. So they say when they first tried doing this, they were limited to hundreds of kilometers, which does no good. Totally valid. That's a pretty crummy FTL drive, given what you guys have. Then he says the Glenn was more successful, and it transported, using this, it went 90 light years in 1.3 seconds. Let's take a minute. Oh, and even better, those 90 light years were in the beta quadrant. So again, trying to figure out the map of where they all actually are. Are they testing out a drive on the edge of Klingon space? That's a problem. That's a problem. But he's assigning a time to it. He says it took they went 90 light years in 1.3 seconds. But then he transports her to these places using these spores that are probably okay. Well, we gotta figure out the distances to these other places that they're going to. I think he mentioned Andorians at one point. We've got to go back and break down where they all actually are. I think I've got So he starts transporting her instantaneously to all these different places, and there's sort of a fuzz, but the implication is that it's instantaneous. Now, 90 light years, let's just try to step back for a second and actually talk about distances in our universe. 90 light years is not that far when we're talking really about the galaxy. The closest star to us is 4 light years away. And as a size comparison, I like to use, imagine an orange in Denver and an orange in Los Angeles. And that's about the size distance of us to our nearest star. Now, our galaxy has hundreds of billions of stars, and they're all, interspersed at different levels. But 90 light years is not insane for traveling around the galaxy. Okay, Neostar said, I was a little confused by that part. Wasn't sure if he was transporting her or simply allowing her to see these locations via the spores. Yeah, but again, how is this all working by cycling potential locations? The implication is that she's actually standing there. And I have another picture from that. Especially this one. Like, this one felt more holodecky than like projection of an image type thing. So I was kind of taking it as that she was physically like moving between them. That's why she was in that chamber. But you could totally be right. It could just be that he was showing her where these spores existed. But again, if he's just showing her where the spores existed, regardless, there has to be some transfer of space, right? Because it's all faster than light. You can't look at it. If you're looking at it normally, it's going to take time for that image to get to you. So any of these instantaneous transporting or just viewing between these things are going to require breaking physics in some way. Now, one thought I did have is possibly quantum entanglement. And I hate coming back to that because I feel like we hardly know much about quantum entanglement just in physics, that we're still trying to figure out. There was like a poorly clickbaity phrased article about how we now have transport technology earlier this summer, that the Chinese transported a photon up to a satellite. That was totally clickbaity. What they did, I think, as far as I understand, what they did is they were able to sustain an entangled state photon into a satellite. And those are slightly different things. If we're going to use quantum entanglement, so for those of you who might not know, quantum entanglement is this idea. Hey, Reef, good to see you. Quantum entanglement is this idea that we have particles and they are existing as sort of within the same quantum state. And then we separate them, whether they're coming from the same progenitor, regardless. We separate them and they can communicate faster than light. This is a thing that we see and we know of, where I poke one and the other one responds instantly. And what we've done as scientists is try to figure out how far apart we can separate them, keep them in this entangled state where you can still do that. So basically try to keep it entangled and see how far away we can do that. All of those are hard to do. But I feel like this season of Star Trek is using, or this series of Star Trek is using quantum entanglement a lot. Because in my last episode with the first two episodes, when Sarek comes to Michael, when she's in the cell, and he projects a mind meld through space and time to her, and we all discussed that was a bit... But again, the only way you could do that is with some sort of quantum entanglement connection. And the way they explained that was that, he mind melded with her when she was dying as a child. And so they have this connection that he can tap into, even though it might do bad things to his mind. So it's possible that something similar is going on here. This idea that all of these spores, all this fungus, is all quantum entangled. And if you're able to tap into that, then maybe you're able to jump in between them and break physics. It's fun. It's cool to think about. I'm a little concerned, maybe, that the writers read some articles on quantum entanglement that maybe didn't explain it very well. And they're trying to use all of this to explain everything. That we don't need faster than light. We don't need to worry about the rules of space-time because everything's all entangled at once at all times, and it doesn't matter. And I really hope that that's not where they're coming from, because Star Trek has always classically been so good at doing things like explaining warp drive and transportation and all these sort of things that are kind of cool and kind of physical. I hope they don't rely too much on quantum entanglement as a hand-wavy explanation, because I can't really think of any other physical phenomenon that could even begin to explain this. So just to recap, because I kind of went away for a bit going on about it. The 3 flavors of faster than light travel that we've seen in sci-fi typically, jump drives, wormhole jump gates, and warp drive. Star Trek has usually used warp drive. That's where you build a bubble around the ship and it takes time to go somewhere. Wormholes are the other thing that's used, and that's like in Deep Space Nine. I've got lots of theories. I could talk for ages about the prophets and the wormhole and how that all works, but that's for another time. So what's going on here? We now have a biological faster than light travel capability. This was my face for about an hour after watching the episode. Why? I suck at biology. Again, we'll try to just say that it's some sort of quantum entanglement. There's no way you can do this with space-time. There's no way. And the other thing, so the problems we have, and we're trying to stay positive. We got to make this work. We love Star Trek. Everything I do is trying to make this sci-fi work and try to explain it properly. So we're sticking with it. We're not giving up on this. Basically, what we have to do is convince ourselves that this fungus spore network exists everywhere. There's no explanation that they have given so far for it to just be isolated to our galaxy. Everything that they've implied so far, every discussion they've had about it, it would have to be permeating the entire universe. They're trying to figure out how far they can ride this. What he shows her could be within the limits of like tens of light years. So there could be this radius where they are, and where she's going to, could be within tens of light years. He says the furthest the Glenn has gone is 90 light years, which took 1.3 seconds to do that. So they're testing out this network. They're trying to figure out how far they can go with it. I think other difficulties that may come into it that they kind of addressed here is that, let me see if I can go back. She's in a chamber, right? So you somehow have to be kind of tapped in. Yeah, veins of the universe, dude. Seriously. So you have to be tapped into this network somehow. And obviously, it's not impossible. Like, it's not hard. They've figured out the technology of taking a human and having them jump around and show up at all these different places. A ship is harder. A ship should be harder. A ship is bigger with lots of humans and lots of biological squishiness. So a ship would be harder, and we're trying to test that out. They've gone 90 light years, which, as the lovely Captain Lorca said, I love Jason Isaacs. He said they ended up in the beta quadrant. So they must be within 90 light years of the beta quadrant, at least. So I've got to, just for my Star Trek brain, figure out where they are. So we've got the spores have to be everywhere. They have to be able to exist in a vacuum. They could be dark matter, but don't quote me on that. I'm just going to try to use that as an explanation for why they could be there, and we've never seen them before, because it's kind of dark matter, acts weird. We don't know what it is. It's the best analogy I can kind of give to this. Do I think it's a biological being? No. Period. Full stop. That's my official statement. But Star Trek is giving us something else to work with, so we're working with it. If they're going to jump between point and point, the most likely explanation is some sort of quantum entanglement idea. And I guess what I'm trying to say with that is that somehow you would have to encase the human or the ship in all of these spores, and then they just show up where the other spores are, which is kind of like quantum entanglement. You poke one, the other one reacts instantly. Okay. Maybe they're using transport. I'm not even going to get there. So yeah, weird. Can I just take a second and say, why did they give me biological FTL to work with? Like, I'm so stressed out about it. I had a stress dream last night about this. Okay. So yeah, 90 light years in 1.3 seconds. I've got to do the math with warp drive, because I feel like warp drive is actually faster than that. Like, when you get up to, like, warp 9, we don't go above warp 10, because you know why. And the last point that I wanted to talk about with this, because I actually had to go back and rewatch this, was, I was like, well, what about the water? Like, remember, well, we're going to go back. Does that go back? Yeah. House. It's not the first biological drive in Star Trek, though. Yeah, true. If I remember correctly, but we'll come back to that. So the water droplets here, I couldn't remember where they were coming from, and how they explain them, because this isn't fungus. This isn't some weird thing. And what he says later in it, he references the black alert, and he says that they ran into a thread of the mycelial network, which made things damp, which I really have a problem with. Just because water doesn't do good in space. Water doesn't do good in space. You can't run into a network of fungus and get damp if the fungus is in space, because water boils away because there's no air pressure to keep it water. And he said damp, and that looks like water, and it splashed like water. Maybe it's a weird thing within the ship, but again, that water would have to be contained somehow. Maybe within the mycelial fungus. I'm throwing a lot. I'm in like biological technobabble mode. I can do physics technobabble. I can do engineering technobabble. I don't know biology well enough to be able to speak in any authority of this. So he says mycelial network. We're going with that. I promise I will rope in my biology friends to help explain this, because sorry guys, that has to happen now. So yeah, this running into a thread of the mycelial network made things damp. Apparently, full stop. And Swizzle said, maybe the fungus is created from their bath mats after they shower. I mean, valid, right? I originally, when I saw this scene, I thought maybe there was like some super condensing of water particles in the air that were like falling out and then dropping, and just some weird effect that was going on. I didn't really think that it would be a network thread of fungus that they ran into that made things damp, that made the water float. But yeah, I mean, post-shower fungus, sure. Biology is gross and squishy. I do space. Speaking of space, we're going to end. I wanted to end on a geeky, happy, fun time note. So for those of you who joined later, I see we have a few more viewers than before. I threw this image in. This isn't from the episode. This is when the engineer is talking about the tie between biology and physics, that physics is biology, and at the core, they're all the same thing. And this image is a simulation that scientists have done of the structure of our universe. So this is what they're alluding to when they're talking about that, because it looks like neurons, it looks like fungus, and this is actually the structure of galaxies in our universe. So really cool. How they got from this to fungus exists in our universe. I'll save that for my stress dreams. All right, but carrying on, let me see. So the last I just wanted to show, because space is a happy place. We like space. They use ion showers in Trek. Yeah, they do. So, I mean, but maybe there's there is water vapor in the air, right? So like there is fungus in the air. Squishy. Gross. But true. Because there's humidity, and we need humidity, relative levels of humidity. So there is fungus that floats around in an atmosphere, but in the vacuum of space, that's harder. So yeah, not ideal. It's all Q's doing. Oh, Q making the fungus for FTL. How perfectly frustratingly brilliant would that be if John Delancey just showed up? It was like, suck it, losers. That was me. I mean, respect. You'd get the Trek nerds bowing down at that. I mean, I'm not a fan of Q because he's a bringer of chaos, and I don't do chaos. But it would be poetry. For all the hardcore Trekkies, it would be poetry. for it to be a Q network of fungus. Valid. I'm going with that. That makes me happier. That's going to make my dreams better. Gross. Q and fungus in the same sentence is not really happy either. Second judgment of humanity. You're not wrong. Oh, yeah. And you brought up, too, House, you brought up the biological drive in Star Trek. Yeah, I feel like there's been a few of these sort of weird illusions. There's weird, energy beings, I mean, that's like the original series type stuff that they have, where you have biological beings, but they're made of energy. And then there's a Voyager episode, wasn't it, where it's like a space whale that they were stuck in, that I think was going faster than light. Wasn't it? I need to watch it again. To be continued. TNG Farpoint episode. Yes! Okay. Oh, man. All right. It's been a while since I've watched that. It's just Q sweat. It's disgusting. Now we're going to give me a whole other group of dreams that we don't need to have. Q and fungus. Q and sweat. Going to a bad place. Yeah, Farpoint episode. Premiere Farpoint. I'm going to rewatch that. To be continued. I will bring that up next time. Thank you. Because it's been a while since I watched that. So, and I feel like there was a handful of other, at least allusions to biology. I'm making a note. Carry pens and notebooks around. All right. And then this was a really pretty shot of a sun that got me back to my space happy place. You see flares and coronas, and it looks like an M-class star, and we're good. Yeah. There was a few, but that's a good one, though. Thanks. I need to just stop watching Voyager in all my free time and actually go back and rewatch Next Gen, because it's been a while since I've watched it all. I mean, I've watched it all many times, but it's been a while, so I'm going to do that. Okay, that's an hour. We're up to an hour. I'm glad we were able to vent about this for an hour. And House, come hang out here. It's fun. We'll talk science. You can ask any questions. We're here to talk science. Again, I am hosting the Real Scientist Twitter page this week. If you want to donate, that's always much appreciated. I have a button down here you can click on to help support me make these videos. I have VODs that come out on Thursdays. This one is going to be really fun. I'm talking about gravitational time dilation, and I actually had a blast just even rewatching it when I was cutting it together. So it's really fun. And then we'll do this again next week. We'll talk about the science of the next episode of Star Trek Discovery. And until then, thanks for hanging out with me. Are there any last questions before we go? Maybe? All right, we'll call it there. Hit me up on Twitter if you've got anything else. I'm going to watch some of these episodes and try to figure out the other biology things. Thanks, Neo. This was fun. I'm glad you guys came. I know, too many. That's okay. That's okay. We've got time. We're going to do this. I keep doing it. I'll see you next week. Thank you again. Thanks to everyone who followed and for showing up. Live long and prosper, and I'll catch you next time. See ya.